Okay, since there's three variables in here, I think it's important that you do it on RF first, because if you start off and let's say you get x equals 2, and then you keep doing the problem, it's just gonna get uglier and uglier, and you won't realize you're wrong until the very end. So I say do RF first so you know what answers you're looking for. So in this case, the matrix is going to be 2, 3, -1, and 0, 1, -2, -4, and 14, 3, 1, -8, and 17. And when you finish, you should have a matrix that looks like 1, 0, 0, and a number, 0, 1, 0, and a number, and 0, 0, 1, and a number. And that first number would be the x, the y, and the z. So go ahead and put it in matrix. What is the size of that matrix? It's a 3 by 4. So you have to change your side. We've been using 2 by 3. So now we're going to do a 3 by 4 and key it in. Make sure you keyed it correctly, and then do RF to it. So when we do RF, we get x is 4, y is -3, and z is -1. So we know those are the answers we're going to be looking for when we do it in real life. So the first step, it says eliminate one variable using equation 1 and 2. This is a systems of equation. Every equation needs to be used at least once in order to come into the party and be part of the solution, right? It's like a committee. Everybody has a say. So when you use the first two, if you follow my rules in general, and you use the first two, you already got 2 out of the way. And then when you use the second 2, you get the third involved, and then you'll have a correct answer, okay? So what can we eliminate quite easily in the first 2?
Z and X.
The x is good. The z, we could do the z too, but the x is the easiest. Okay. So we multiply that second guy by -2, and we rewrite these equations. So we have 2x plus 3y minus z equals 0, and -2x plus 4y plus 8z equals -28. I just multiplied by -2. So now I add these two together, and we're right, the x's bit the dust, and we have 7y plus 7z equals -28. So now we got to get the other 2 equations into the party. So we're going to take the second and the third equation, these 2, and eliminate. This is the thing people don't do. You have to eliminate the same variable. So if you eliminated the z on the first run, you have to eliminate the z on the second run. But we eliminated the x, so we have to eliminate the x. So to do that, we have to multiply that second guy by -3. Does everybody understand that?
So the second one this time.
Yep. So now we have -3x plus 6y plus 12z equals -42, and 3x plus y minus 8z equals 17. So our second equation, x's bite the dust, perfect. 7y plus 4z equals -25, I believe it is. So let me check that. So if you feast your eyes now, I have 2 equations with 2 variables. Well, that's what your test was on yesterday. So you guys are pros at this. We're going to write down the first one, 7y plus 7z equals -28. And then the second one, 7y plus 4z equals -25. And we have to find a way to eliminate one of these variables, which I would eliminate the y. Yeah. If I change all of these signs in this equation and add them together, the y's bite the dust, and we have -3z equals 3. So z equals -1. Well, we got z.
Wait.
So now we know z, so now what do? We used to plug in the original, so 7y plus 7z equals -28. We plug in the -1, 7y minus 7 equals -28. 7y equals -21. Y equals -3. Did we find y? Looks like it.
Found Z. Wait,
So far, so good. Look at your matrix. It was 4, -3, -1. We found z and y, so we're good. And how do you think we find x?
Plug in both.
Plug it into one of the original equations. So we have 2x plus 3 times -3 minus -1 equals 0. 2x minus 9 plus 1 equals 0. 2x equals +8 when you move it to the other side. And x equals 4. So we nailed all three of those. We got them.